Let's solve this trig equation. It's quadratic, and it's a little tricky because we're going to see that we're going to need a calculator. So first we'll start out by factoring. And this part's not too complicated. It's a quadratic, and it will factor nicely into 4 tan minus 3 times tan theta plus 2. Let's double check. The first is 4 tan squared. The last is minus 6. The inner is negative 3 tan. The outer is plus 8 tan. And 8 minus 3 is 5. So that works. Now we apply the zero product rule, and we get tangent of theta equals 3/4, or tangent of theta is equal to negative 2. Neither of those are familiar ratios, so we're going to have to go to the calculator. Let's look at tan of theta equals 3/4. That's a positive tangent value, and those will be in quadrants 1 and 3. So we're imagining, and they're pi apart. So we're imagining these two solutions in quadrant 1 and quadrant 3. Now, typically, what we will do is use a reference angle. The reference angle is always the positive acute angle between the terminal ray and the x-axis. So our quadrant 1 solution and the reference angle are the same. We take inverse tangent of 3/4. We type this into our calculator. Let's go ahead and just round to 1 decimal place, and let's use degrees. Degrees are much easier to work with when we're dealing with non-special angles. So we get 37.9 degrees for theta prime. So this tells us that our group of thetas are 37.9 degrees plus 180k. And that will take care of the quadrant 1 solutions and the quadrant 3 solutions at the same time, because we're jumping by 180 instead of 360. Let's take a look at the second group. Here, our theta prime will be the inverse tangent. And to get a reference angle, we have to take the absolute value of the right-hand side. So that is going to give us, when we type it into our calculator, 63.4 degrees. Okay, tangent of theta is negative 2. That's in quadrant 2 and quadrant 4, and those are 180 degrees apart. And the reference angle for quadrant 2 angles is right there. The reference angle for quadrant 4 angles is right there. So what this means is that we have to subtract the reference angle from 180 to get theta in quadrant 2. So when we subtract that from 180, we're going to get 116.6 degrees. Now we don't really need to find this quadrant 4 solution because the quadrant 2 solution plus 180 will get us there. So this will be the set of all solutions, the combination of these and these, the red and the purple angles. That gives us all solutions. Now, quite typically, we're asked to find the set of angles in the interval 0 to 2 pi. So if we're trying to do that, we would have 37.9 degrees. And then we would add 180 degrees to that and get 217.9 degrees. And then we'll go to our purple angles and we'll get 116.6 degrees. And then we have to add 180 degrees to that, and that will give us 296.6 degrees. So those would be the 4 solutions between, and I said between 0 and 2 pi, but if we're going to do this in degrees, I should, more correctly, say that this is between 0 degrees and 360 degrees. Nice.